Hi everyone, in this video I'll walk you through my high availability PostgreSQL setup. It includes automatic failover, load balancing and a disaster recovery site. I'll show you how 3 Postgres instances on my primary Proxmox cluster stay in sync, how pgpool-II manages traffic and leader election, and how my DR site is always ready to take over. We'll finish with a live demo of creating data, watching it replicate everywhere, and simulating a primary server switchover, all without downtime. So let's get started. For internal projects, my go-to is PostgreSQL. It's open source, standards compliant, fast, scalable, and packed with features. From a cloud provider's perspective, I also keep other options available, like MySQL, MariaDB, and SQLite. But regardless of database, high availability and disaster recovery are essential. My setup: I run 3 Postgres VMs on my Proxmox cluster: B100 pggrf1, B100 pggrf2, and B100 pggrf3. One is the primary, with synchronous replication to the other 2. For disaster recovery, I have 2 VMs on a separate Proxmox node, B100 pggrf4 and B100 pggrf5. A secondary from the primary site replicates asynchronously to B100 pggrf4, which then replicates to B100 pggrf5. In production, the DR site would mirror the primary to ensure smooth failover. In addition, the cluster on the primary site would consist of 5 VMs, being part of a failover configuration. Failover and load balancing. For load balancing and automatic failover, I use pgpool-II, with an instance running on each primary site VM. pgpool-II's Watchdog elects a leader via quorum. The leader holds a virtual IP that clients connect to. Read-only queries are spread across all 3 instances. Read-write queries go to the primary. If the leader fails, another is selected and takes over the virtual IP, avoiding split brain. If the primary Postgres instance fails, pgpool-II promotes a standby and removes the failed node. Let's now start with a demo. We'll use TMUX with 3 windows, each serving a different purpose. Window 1, used for monitoring pgpool-II. Panes 1 to 3 show PCP node info for each Postgres node. B100 pggrf1 is primary. B100 pggrf2 and B100 pggrf3 are standbys in sync with quorum. Pane 4 shows the pgpool watchdog. B100 pggrf3 is the leader and holds the virtual IP. B100 pggrf1 and B100 pggrf2 are standby. Pane 5 is my command pane, logged in as Postgres user. Pane 6 is on a Proxmox node. I'll use this later to trigger a hard failover. Window 2, Postgres control. Pane 1 connects through the load balancer, B100 pggrf-LB, port 9999. I'll run SQL commands here. Panes 2 to 6 connect directly to each VM. Each is running a watch on table test table. Window 3, DR site. Logged into B100 pggrf4 and B100 pggrf5. Used to check replication and reset after failover. To the demo highlights. The VIP is 10.1.10.105, currently on B100 PGGRF3. The top left pane, I have a load balanced connection, /coninfo confirms it. The other panes, direct connections to each VM. To the replication flows. B100 PGGRF1 indicates synchronous replication to B100 PGGRF2 and B100 PGGRF3. B100 PGGRF2 indicates asynchronous replication to B100 PGGRF4. And finally, B100 PGGRF4 shows asynchronous replication to B100 PGGRF5. I am creating table test table, change ownership and insert a row. Please pay attention to the 5 watch sessions. You will see how these changes progress through the replicated databases. Simulating maintenance. If I need to patch the current primary, node 0, I can promote another node, for example node 2. Please watch the 3 topmost panes. You can see that one of the 3 Postgres instances is always accessible to users through the load balancer during the entire switchover process. Now node 2 is primary, node 0 and node 1 are standbys. You can see here that the switchover broke DR. I will be fixing this first. First, I'm making sure the replication slot for B100 PGGRF4 still exists. I'm stopping Postgres and I'm rewinding the database. This means that Postgres is resyncing the delta differences using the write-ahead log segments and the archived WAL files. This now overwrote the connection string and the application name contained in the myrecovery.conf file. I am replacing the file from a backup. I restart Postgres and it should now be syncing. I recreate the replication slot for B100 PGGRF5. I fix B100 PGGRF5 next. This follows the same process. Shut down Postgres, rewind the database, restore the original connection string, start up Postgres. With the R side is in sync with the primary once again. You can see the result here. I can safely perform maintenance on node 0 and rejoin it later. One of the drawbacks of only having a 3-node cluster: if one of the 2 remaining nodes fails now, the cluster will lose quorum and the system would be down. This is the main reason of having a cluster of 5 or even 7 instances. I create an additional entry and test table to simulate activities during maintenance. But just adding one entry is not enough to truly get the databases out of sync. After maintenance, I need to bring the database back in sync with the primary. This could be done using the pcp recover node command like so, but this would take a new base backup of the primary and restore it back to the standby. This is definitely acceptable for such a small database, but if this would be a multi-terabyte production database, the backup restore would take too long for my taste. To simulate that case, I will once again use pg rewind to bring the databases back in sync, because this would just restore the delta using the wall and the wall archive. As already mentioned, the activity here was not enough to truly get the databases out of sync, and I could have just reattached it to the cluster. I'm reattaching it now. This concludes the maintenance, and I can insert an additional row. Quite a few tasks performed during this maintenance activity can be scripted, and that's something that I put on my to-do list. The demo so far covered a controlled failover, but the real test is an actual failover after the primary instance failed. First, I'm testing pgpool-II. The virtual IP address is currently owned by B100 pggrf3. I'm failing pgpool-II on this VM to trigger a failover. The virtual IP address failed over to B100 pggrf2. This happened almost immediately. Right now I'm running on 2 instances, and adding another entry to my test table works without any issues. Now I'm starting pgpool back up on B100 pggrf3. Adding another entry to my test table works without any issues. The ultimate test: shutting down the primary Postgres VM. Current primary is node 2 running on B100 pggrf3. Within prxsrv2, I am executing the stop command for VM P100 pggrf3. As soon as I am hitting enter here, Proxmox will shut down VM P100 pggrf3 hard, as if somebody was pulling the power cable. This should trigger a failover. After a very short while, I now have a new primary. I am still able to add an additional row to my test table. That's my short overview of Postgres with pgpool-II for HA and DR. Follow-up videos will cover configuration files, scripts, and a GitHub repo with everything you need. If you found this useful, subscribe so you don't miss the deep dive content coming next. Thanks for watching.